This lesson is the rich set of C# operators. Our objectives for this lesson are to learn the operators that are available in C#, to see the mathematical operators in action, look at the usage of compound assignment operators, look at the correct usage of the unary operators, using the relational or comparison operators, and combine the expressions using logical operators, and finally, learn the order of precedence for all of these operators. In computer programming, an operator is simply a symbol that performs a mathematical operation on two or more operands, or performs some sort of relational operation. So examples would be addition, 1 plus 2, subtraction, 4 minus 3, or less than, 3 less than 4. We have all the standard mathematical operators: addition, subtraction, multiplication, and division. In C#, we also have compound assignment operators that are used to apply a math operation to the same variable. For example, value plus equals 10 is the same as value equals value plus 10. And in all the other ones too, value minus equals 5, value times equals 2, value division equal 2. Let's take a look at the mathematical operators in C#. Let's start out by looking at some addition. So let's create a decimal called price, and we'll set it equal to $1.99. Now I can either do M lowercase or M uppercase. Either one works. The compiler really doesn't care. Then let's do price equals price plus 10. And then we'll do a console.writeLine on price. And if we run that, you should see we get the value $11.99. We can also switch this to that compound assignment as well, where price plus equals 10, and that does the exact same thing as the addition that we just did. Let's now do subtraction, price minus 10. So if we do this, obviously we're going to get a negative value. Probably not something you want to do. So hopefully we would start out with something as a price of $11.99 and we'd get the price of $1.99. And again, we can also use the compound assignment. We can also do multiplication. So we could do price times equals 2, for example, or price equals price times 2. Either one works. And we get $3.98, as you'd expect. We can then do division as well. If we put this back to $10.99, and we use the division symbol, or we can use the compound assignment, we should see the result of having that number. Now, I didn't have these on the slide, but one of the things you can also do is exponentiation. So we want to get an exponent. So I'm going to go ahead and make this, let's make this $5.99. And then let's take the cost and set it equal to Math.Pow, right? We're raising cost to the third power, like so. And then we can print that out. So in this case, we're using a math class that has a power method on it, right? So you're raising this to the power of, in this case, 3. We run this, and we can see the result of $5.99 times $5.99 times $5.99. That's what exponentiation does. Another one that I didn't mention, but is also available to us, and that's integer division. So if we have an int, maybe quantity, and we're equal to 10, if we were to then do quantity equals quantity divided by 3, now this uses integer division now. So it's not going to convert this to a double or anything. So what we're going to get is a whole number. Okay, so 10 divided by 3 is really what? 3.3333, whatever it is. Okay, but in this case, it's going to truncate that remainder because we're working with integers. And then the last one we have is integer remainder. So if we put a % sign there, and the operands are an integer data type, the result will be an integer. So if we run this now, it shows us that, yes, there is a remainder, okay, in this case, a remainder of 1. If I change this to a 2, it should be 0 because there is no remainder because 10 is divided by 2 equally. Another great feature of C# is unary operators. This is where we want to simply add 1 to a variable, and we can do addition or we can subtract 1 from a variable using minus minus or plus plus. And that operator can go before or after the variable, and it makes a difference. So let's take a look at how it makes a difference by studying the unary operators. Let's start out looking at this code here. I've created int index equals 0, and I'm first going to do a post increment. So I'm going to do a council.writeLine index plus plus. What's interesting is what is the first council.writeLine index plus plus going to report, and what is the second one going to report? The first one is 0, and then the second one is 1. If we look at this, what we can see is that on line 4, council.writeLine index plus plus, since the plus plus comes afterwards, it reports the value of index first to the council.writeLine and then increments the value. So that's why the second council.writeLine, where we're just outputting index, is the value of 1. Now let's add on a pre-increment. So you can see here on line 8, council.writeLine plus plus index, and then another council.writeLine on just index. What's going to happen here is that it's going to increment index first, then it's going to give the value to council.writeLine. So let's go ahead and take this one out, and let's now run this one. So in this case, what we're going to get is a 1 and then a 1, right? And you can see that because we put it beforehand, so it increments first and then returns the value. We also have a post decrement that we can do. So in this case, I've got int index equals 0 on line 1, and then on line 4, I'm doing index minus minus. So if we run this, we should get a 0. It then decrements, so the next line on line 5, when they do the council.writeLine on index, it says it's now the value minus 1. And we could change that to a pre-decrement if we wanted, simply by adding the minus minus in front, and now we will get a minus 1 and a minus 1. Besides mathematical operators, we have relational or comparison operators, where we can test to see if something is greater than something else, something is less than something else, or something is equal to. Now, the equal to is double equal sign. Single equal means you're doing an assignment. To test for equality, you do a double equals. We also can do greater than or equal to, less than or equal to, not equal to, which is an exclamation point equal sign. So let's take a look at relational operators in action. Let's start out with the less than relational operator. So in this case, I have decimal cost equals $4.99, decimal price equals $5.99. And what I want to find out is cost less than price on line 5. So this should return a true because cost is less than price. We can then change this to greater than by simply changing that to a greater than sign here and running this, and that should then return a false. We also can do less than or equal to. So less than or equal to, and this should also still return a true. Now, if these were exactly the same, then it should come out true. We could then change this to a greater than or equal to, just by changing that symbol again. This should now come out as a true, but if I were to change cost back to $4.99 and run this, it will now come out to a false. We also have equal to, so simply an equal to right here, and this one should return false because $4.99 is not equal to $5.99. But again, if we change this and rerun it, they are equal. Now remember, you must use the double equals. If you do this, let's watch what happens. Okay, it just comes out and says, oh, it's $5.99 because it's done an assignment. Okay, So if I had cost at $4.99, price at $5.99, it's still going to come back as $5.99. If this was $6.99, it's assigning price to cost, and that is then what is being returned. We can also do an not equal to, just by doing an exclamation point equal, and that should come out that it is true. If I change this to a $6.99 and run this, now it's equal to false. If we want to compare two different expressions, we can use the logical operators of C#. We have a not operator, we have a logical and we have a logical or. So hard to explain these until you see them, so let's go ahead and take a look at the logical operators. So the first one we're going to look at here is the not. So I've got bool is active equal true on line 1, and then on line 4, console.writeLine, the not of is active. So if we negate this, true becomes false. So if we run this, it should report a false. So that's the not operator. Let's then take a look at a logical and. So what I'm going to do now is I'm going to change this. I've got a decimal cost of 0. I got a decimal price of $5.99. I'm going to do a logical and where I want to find out is cost equal to 0 and price is equal to 0. Now, when you're using an and, both sides must equate to true for the whole expression to be true. So in this case, it's false. If I were to change this to 0, now it will report a true because both sides meet the criteria. I could also change this to a logical or. So let's change this back. Let's change this to $5 now. Okay, so for a logical or in this case, if I'm now checking to see is cost equal to 0 or price is equal to 0. So if either side evaluates to true, the whole condition is true. So in this case, it comes out to be true. If I were to just change cost to something else, both sides are now false, so it comes out to be false. Now, I've shown you some very simple expressions here, but there is an order of precedence because if you had several operators occur in an expression, now each part of that expression is then evaluated and resolved in a predetermined order that is called operator precedence. The way they go is first arithmetic, then comparisons, and then logicals. Microsoft has a complete list of all of the operator precedence that you can get at this URL right there. But basically, if multiple operators occur in an expression, they are evaluated in the following order. Arithmetic operators first, multiplication and division in the order they occur from left to right, then addition and subtraction in the order they occur from left to right. Then comparison operators in the order they occur from left to right, and then logical operators are finally evaluated. The above can be overridden by wrapping any of the individual expressions within parentheses. So an example would be, let's say I've got an integer a equals 1, an integer b equals 2, an integer c equals 3, and then a result. If I say result equals a plus b times c, can you guess what the result is going to be? Now remember, multiplication and division happen first, then addition. So the result in this case will be 7. If I enclose in parentheses the a plus b, remember parentheses give that expression a higher order of precedence, so now the result is 9. In this lesson, we looked at all of the standard math operators available to us in C#. We talked about the compound and the unary operators because they can save some typing. We saw the relational operators, how we can do comparisons between two different things, and the logical operators that let us combine multiple expressions. Beware and pay attention to that order of precedence. And again, you can override that with parentheses. Coming up in the next lesson, we'll talk all about if and switch statements, ternary and null operators.